So there are some common logarithmic functions that we use, and they're used so often they're given special names and they're given a shorthand. So we'll do those two now. So the first one is called the common logarithmic function. So which we want to write as the logarithmic function base 10 is called the common logarithmic function, the common log function. So what this says is if we're given y equals log base 10 of x, then that's equivalent to the same thing as y equals log x. Alright, so this is equivalent to saying if we had x squared plus 3x minus 4. What's the coefficient of the x squared? If nothing's written, then it's a 1. That's what we're doing here. We're saying that 10 is similar to that. So 10, if there's nothing written, if there's no base written right here, that means that it's base 10. All right? And then we have another one that's very common. And here comes E again. The logarithmic, I'm going to just say log function base E is called the natural logarithmic function, the natural log function. So what that's saying is if we have y equals log base E of x, that's equivalent to, and this one's a little different here, that's equivalent to saying the natural log of x, so ln x. Why it's backwards, I'm not sure. My guess is that the L looks like a 1, I don't know. But that's why this is what we have. If you see this natural log of x, that's meaning that we have a log base of E. And so we're going to look at some examples now, similar to the examples we were looking at earlier, where we're just converting or evaluating. So let's look at this. Let's say evaluate, and this time we're actually going to have to solve for something here, but these will be incorporated throughout. So part A, log of 100,000. All right, so this is different than what you've seen before. Well, what I've shown you before is I said this was equal to something, and all we did was converting. But now I actually want you to tell me what log of 100,000 is equal to. So the way you start is if you need to set it equal to something, so that way we have something to work with here. So log of 100,000, and let's set it equal to y. It can be equal to any number, any letter you want. I'm just choosing y. All right. So something else I need to be aware of here is, what is my log base? My base is 10 because there's no base written. You have to come back up here. If you have log of x, that means that we have a base of 10. But you're going to see this from now on, just log x. And you're going to see the natural log also. You won't see these anymore. All right, so if it helps, for an example or two, just write it in there so you remember. All right, and then from here, so what we've done, we've set it equal to something, y, and then from here it works exactly like we've done. We're in logarithmic form, so we need to convert to exponential. That's going to be key throughout the next couple sections, is recognizing you're in logarithmic and then converting to exponential and vice versa. So to go to exponential form, I need my base, which is 10. And my exponent, remember my exponent is what's by itself away from the log, because we have logarithmic form to help us solve for exponents by themselves. 10 to the y power is equal to 100,000. All right? And then what we can do is, well, how can you rewrite 10 to the y power? Rewrite 100,000. So you get 10 to the y. Some of you can tell me this in your head. I'm just writing it out. You can rewrite this as 10 to the 5th power, which means y is equal to 5. Some of you could have just jumped here, and that would have been fine. But this is going to be an important rule come in a section or two. Let's try part B. You try this one, log of 1,000. All right, so I need to evaluate this, so I need to set it equal to something. Then that allows me to start working with this and manipulating it. So now I have it in logarithmic form. If I convert it to exponential, maybe that will help me with my answer. So I know my base is 10 because nothing's written. That means it's 10. Then my exponent is y, and that's equal to what's left over. So I know y has to equal 3, or 10 to the y is equal to 10 cubed, so y is equal to 3. And that would be your answer here. This is going to be part C. The natural log of e to the 4th power. All right. So this is different. I'm not sure how to do this one. This ln is throwing me off. All right. What did ln, the natural log, mean earlier? So let's look at it. If we have the ln of x, ln of something, that means I can rewrite it as log base e of that something. So let's try that for this first one. And then, so we have the natural log of e to the 4th. This natural log is the same thing as log base e. So this natural log just becomes this log base e portion. And then we still have this e to the 4th left over. So that has to go there. All right, and then we need this equal to something, so let's set it equal to y. And from here, go ahead and pause and try to finish it out yourself. From here, it works the same way we've done before. My base is e, and that's my exponent is y, what's all by itself. And then that's equal to what's left over. What's left over is this e to the 4th. So that tells me that y has to equal 4. All right, and there are some shortcuts throughout all these examples, and I'm not going to explicitly say all of them right now, but we're going to get into that shortly. Let's see. Yeah, we're going to get into those now, actually. So what I want to do is I'm going to go through a bunch of examples, and the book has a list of all the I don't want to say shortcut, they call them properties. I'm not a big fan on memorizing all these properties, because as long as you know how to do the work here, as long as you know how to do one system, converting back and forth, then these answers just pop out. So I don't want you memorizing all these different types of properties. I want you to know how to actually convert these back and forth, and knowing that simple thing, eventually as you do more and more of these examples, some of the shortcuts will just pop out to you. So let's look at this. Example 2, and let's say simplify. All right, part A, log base 3 of 3 to the 10th power. All right, so try this one. So you first have to set it equal to something. And then convert it to your exponential form. So let's set this equal to y. So my base is 3. My exponent is y, and that's equal 3 to the 10th power with what's left over. So that tells me y has to equal 10. Do you see the shortcut here? And the shortcut is if your base and this number, the base of what's left over, are the same, then your answer is just that number up here. Again, you don't necessarily have to remember this. As long as you know how to write these two steps, which are fairly simple, the answer just pops out. And as you do more and more of these, you'll just remember them. All right, let's try part B. Natural log of e squared. Pause the video, try it yourself, and see if you can figure out what the shortcut is. All right, but remember, I always want you to know how to do these steps, because this is how you always get the right answer, not by some shortcut. So let's set it equal to something, and I don't quite yet remember what the natural log is, or how to do this without converting it. So let's convert it, and then let's see if that helps clarify some things. So this is log base e. Remember, natural log is log base e, and then this e squared is left over. Now convert to exponential form. My base is this e, my exponent is y, and that's equal to what's left over. So y is equal to 2. All right, so what do we have here? Let's come back up to this step first. We have this e and e, similar to this problem over here, this 3 and this 3, and this answer was 10. So this is the same property. These e's cancel out, and your answer winds up being this 2. But we can take that a step further if we come back up here. The natural log and e, they're inverses of each other, so these cancel out, and so you're just left with 2. All right, let's try one more of those. C, natural log of e to the 5th power, let's say. Well, natural log and e are inverses, so those cancel out, and the answer is 5. So it could be that short. All right, but it's helpful to know how to work these out too, because there are going to be cases where you need to. This won't always just be 5. There could be something else. So I know that this is log base e. E to the 5th is y. So my base is e, exponent to y, and that's equal e to the 5th power. So y has to equal 5. Next up, part D. Log base 11 of 11. All right, we need to set this equal to something, so let's call it y. And you can actually tell me the answer based on part A and B, but let's work it out. And then, if I'm unsure of a property or a shortcut, then just work it out. It's 2 steps. It's not that long. So I know my base is 11. My exponent is y, and that's equal to what's left over, 11. So that means that y has to equal 1. If I come back up here, this 11 and 11 is the same as this 3 and 3, where my answer was 10. So this 11 and 11, this is actually raised to a 1 power, so that's my answer is 1. So those are the same property, just with the 1, sometimes that throws you off. If you don't know off your head how to do something, if you can't learn the shortcut ways, then it's literally 2 steps. Please do this. I would rather you do this than know all the shortcut ways and accidentally get some wrong. All right, what about log 10? All right, again, let's convert it. The base is, well, there's nothing written, so that means it's 10. Oh, I forgot to set it equal to something. So, and that's okay. You can go back and do it. 10 to the y power is equal to what's left over, which is this 10. So y has to equal 1. So this is the same as part D. There's a 10 written here, or there's a 10, there's an implied 10, we just don't write it. 11 to the 11 is equal to 1, so this is 10 to the 10 is equal to 1. All right? F. Log the square root of 7 of 1. Log base square root of 7 of 1. So we need to set it equal to something. And pause the video. Go ahead and try it. My base is the square root of 7. My exponent is y, and that's equal to what's left over, 1. So for this to be true, y has to equal 0. Anything to the 0 power is always 1. G, natural log of 1. All right, well, if the natural log's still giving you trouble, that's okay. Just set it equal to something, and let's rewrite it. Log base 1 of y. Log base e of 1 is equal to y. So my base is e, my exponent is y, and that's equal to what's left over. So whoa, look here, same thing. So this tells me y has to equal 0 also. So these are essentially the same form. If you have just a 1 here by itself, then the answer is always going to be 0. If you have a 1 here, the answer is always going to be 0. Again, you don't have to remember it as long as you know how to do these 2-3 steps. All right, this next example is unfortunately one I guess you don't have to remember it. There are steps to it, but it is a little difficult. So I'm just going to give this one to you. Let's say if we have 5 raised to the log base 5 of x plus y. All right, so 5 is your base, and all of this is in the exponent, and this is your base too. So let's just set this to, let's call it m. It can be anything. All right, so what happens is this 5 raised to this log base 5, these just cancel. So that means x plus y is equal to m. All right, and that's one just to remember. And that's always going to be the case for any of these.